Okay, so today I'm going to show you how to set up these word problems. Because you should know how to solve these word problems once you get them set up, because they're just like yesterday's example and the day before example. So if you're confused or stuck on that part, go back and watch the previous video from Wednesday, and I'll try to have something also posted for Thursday, even though it won't be the best. So in this, I'm going to read through, and we're going to see how many variables we have to start out with, and then we'll try to set up all the equations. So it goes first, the sum of three numbers is 24. So now I know how many variables I have. I have three. I have x, which I'll make my largest number. I have y, which will be my middle number. And I have z, which will be my smallest number. Now we'll write some equations based on that. So it says the sum of three numbers is 24. Well, the sum of three numbers is 24. I can do that. I can go x plus y plus z equals 24, because that's them all added together. It says twice the smallest number is 2 less than the largest number. So that's a bit of a mouthful. Twice the smallest number is 2 less than the largest number. So if I think about this, if I times the smaller number by 2, and we said the smallest number is z, so if I times z by 2, and I take 2 less, so if I subtract 2, that should be the largest number, which would be x. And it says the largest number is equal to the sum of the other two. Well, that's easier, because that would mean the largest number, which would x, would equal the sum of the other two, which would be y plus z. And now I have three equations. If you think about what method I would probably want to use, I'd probably use substitution. Because I have an x solved here, I have an x solved here. It might be really easy to put those two x's together, or plug an x in and try to see what I can eliminate. But that's the basic setup for this one. I'm going to set up one more. Okay, so here's a second problem. A theater has tickets at $6 for adults, $3.50 for students, and $2.50 for children under 12 years old. And so instantly I can look and say, oh, I have three variables again. I have adults, which is how many tickets they'll want to know for those. I'll have how many tickets they want to know for students, and I want to know how many tickets they'll want for children. So now the next part is figuring out the important information. So they told me $6 for adults, $3.50 for students, and $2.50 for children. They told me that it said it has a total of 278 tickets. Well, it's got a total of 278 tickets. If I took the adult tickets plus the student tickets plus the children tickets, well, that should equal 278. And then they said they were sold for a total revenue of $1,300. Well, if they were sold for a total revenue of $1,300, then that means they equal $1,300, and I got to think what equals $1,300. Well, if I was going to find my revenue, I'd take the total number of adult tickets, which would be A. I would times it by the amount, which is 6, and then I would start adding that to the other things, which would be like $3.50 for the students and like $2.50 for the children. Then my last sentence that they kind of give me information on is the number of adult tickets were 10 less than twice the number of student tickets. Well, the number of adult tickets was twice the number of student tickets, and it was 10 less. So again, this problem kind of lends itself to substitution more than elimination, but if you really wanted to, you could move that to the other side and get in standard form and then use substitution or elimination for everything. But today, the big thing is try to set up the 3 variable equations, and after you've set up the 3 variable equations, you'll go through and solve to find the different answers.